Good morning, children. Sai Ram. Children, today I'm going to start the same chapter of our book, Statics for Economics. That is chapter number 12th, and the name of our chapter is Correlation. Children, this is the third video of this chapter, and in the previous two videos, we have already learned the introduction of the correlation. We do have learned the various types of correlations along with all the definitions and the formula. And in the second video, we do have solved some of the numericals of calculating the correlation by the Carl Pearson coefficient of correlation. Now in today's video we will again continue solving some of the numericals by the Carl Pearson coefficient of correlation, so that you will feel comfortable in solving the numericals. You will know how this numericals can be solved. So let us start with the first numerical, that is we need to calculate the coefficient of correlation. The values of x variable and the y variables are given in front of you, like that is 2, 3, 5, 4, 5, 6, 7, 8. This is the value of x variable, and for y variable we have 4, 7, 8, 9, 10, 11, 14 and 18. Children, as we all know, in calculating the correlation by the direct method, we have a formula, that is r is equal to sigma xy upon under root sigma x square multiply with sigma y square. This formula we need to apply it in calculating the Carl Pearson coefficient of correlation by the direct method. So this is your direct method, and we will solve. First step is we need to calculate the arithmetic mean of x variable and for y variable as well. So we as we know, an arithmetic mean is summation of sigma x upon n. So when we summarize this x variables, we will get sigma x, that is 35, and the number of item is 7. So the arithmetic mean we can easily calculate as 5. And the same we can calculate for y variable as well. The summation of y is 70, number of item is 7, and y variable mean, arithmetic mean of y variable is 10. So once we calculate the arithmetic mean, now the second step is we need to find the deviation, and the deviation will be representing by the small x, and the formula is x minus x bar. Since this is x and x bar is 5 for x variable, so 2 minus 5 is minus 3, 3 minus 5 is minus 2, 4 minus 5 is minus 1, 5 minus 5 is 0, 6 minus 5 is 1, 7 minus 5 is 2, and 8 minus 5 is 3. Once we find out the deviation, now the third step is we need to square the deviation. So minus 3 square is plus 9, minus 2 is 4, minus 1 is 1, 0, 1 square is 1, 2 square is 4, and the 3 square is 3. The same procedure we need to do for the y variable. Children, as we have calculated, arithmetic mean of y variable is 10. So we are finding out the deviation, that is small y is equals to y minus y bar. So this is y, and y bar is 10. So 4 minus 10 is minus 6, 7 minus 10 is minus 3, 8 minus 10 is minus 2, and so on. We are calculating for all the variables. Now, since we have calculated the deviation of y variable, we again, the next step is we are squaring the y small y, that is y square. Minus 6 square is it's positive 6, minus 3 is 9, minus 2 is 4, minus 1 is 1, and so on. Now the last step is we are multiplying deviation of x with deviation of y to get xy. So this multiply by this value and we will get this corner value. So minus 3 multiplied by minus 6, minus minus becomes positive when we multiply both the values, it becomes plus 18. Minus 2 multiplied by minus 3 is minus 6, and so on we are calculating for the remaining values. So once this procedure will be done, we are summarizing each value. So sigma x is 0, sigma x square is 28, sigma y0 is 0, sigma y square is 120, 30, and sigma xy is 58. Now as I just explain you the formula, that is r is equals to under root sigma xy upon under root sigma x square multiplied by sigma y square. Now once we put up all the values, we will get r equals to 58 equals to sigma x value x square is 28 and multiplied by sigma y square is 130. So 58 divide upon under roots 28 multiplied by 130, that is 3640, and once we find out the square root of 3640, we'll get 60.33, and by dividing 48 by 58 by 60.33 we get plus 0.96. So this 0.96 itself is a value of correlation, and this is called a high positive correlation because the value of high positive correlations lies in between 0.75 to 1. Now we're moving on to the next numericals. Children, in this numericals, we need to calculate the Carl-Pearson coefficient of correlation by the shortcut method. The values of x variables are given in front of you. The value of y variable is given here. So we put up here like x variable. So x variable here is 12, 15, 18, 21. 27, 30, and for y variable is 6, 8, 10, 12, 14, 16, and 18. So let me zoom this value so that you can see the values perfectly. So children, for y variable I'm saying the y variables are here. Sorry, x variable is here. X variable is 12, 15, 18, 21, 24, 27, and 30. So we need to assume any values. As I have assumed a value 30, so assumed x is 30. Now the same procedure we need to be done. So x minus, this time assumed x is 30, so x minus assumed x is dx. So 12 minus 30 is minus 18, 15 minus 30 is minus 15, 18 minus 30 is minus 12, 21 minus 30 minus 6, 24 minus 30 is 24 minus 30 is minus 6, 27 minus 30 minus 3, and 30 minus 30 is 0. Now once we get this deviation, we call it dx, and in next step we need to square the dx. So dx square we are doing here. 18 square is 324, 15 square is 225, 12 square is 144, 9 is 81, 6 is 36, 3 is 9, and 0 is 0. So once this work is being done, we are calculating sigma dx and sigma dx square. So sigma dx is, as all the values are negative, so we add on all these values, will get minus 63, that is the summation of sigma dx, and for sigma dx square, that is 819. Now children, the same we need to do for y variable as well. Here is your y variable, and this time we are assumed 10, the assumed mean of y variable. So the same procedure, y minus assumed y, we get small dy. So assumed y is equals to 10. So 6 minus 10 is minus 4, 8 minus 10 is minus 2, 10 minus 10 is 10, 0. 12 minus 10 is 2, then 4, then 6, then 8. Now we are going to square dy square. Minus 4 square is 16, minus 2 square is 4, 0, 2 square is 4 square is 16, 6 square is 36, 8 square is 64. So once this processes have done, now we need to summarize sigma dy. Sigma dy is 14 and sigma dy square is 40. Now the last step is the multiplication of deviation, that is sigma dx into dy. So sigma dx multiplied by sigma dy will get 20, 72, 30, 0, minus 18, minus 24, minus 18, 0, and so on. So once when we finish up all this given calculations, now we are going to apply a formula. So the formula says correlation is equals to sigma dx multiply by dy minus sigma dx multiply by sigma dy upon n upon under root sigma dx square minus sigma dy, sorry, sigma dx का whole square upon n multiply by sigma dy square minus sigma dy का whole square upon n. This is the formula. And r square sigma dx square is 819 minus sigma dx is minus 63 का whole square upon 7 into sigma dy square is 140 and sigma dy is 14 का square upon 7. So 819 multiplied by sorry 42 is sigma dx into dy, so 42 minus 126 this here. So like this we have to keep on the values and simplify that. So 20, 42 minus multiplication becomes positive. So 42 plus 126, that is the numerator value, upon under root 816 minus 3969 divided by 7. So we'll get 567 and 196 divided by 7 will get 28. So 819 minus 567 multiplied by 140 minus 28. So r equals to 168 68 upon under root 252 multiplied by sigma 112. So once we multiply the values, r equals to 168 is on numerator, whereas 252 multiplied by 112 will get 28224, and the square root of 28224 is 168. So in numerator we have 168 and square root of 28,224 is again 168. So 168 divided by 168 we get the correlation, which is 1. So this is the way how such kind of numericals can be solved. Now we'll taking one more numericals to get you understand well. So children, here I'm explaining you the step deviation method of calculating the correlations. So the formula is r is equals to sigma dx dash into dy dash minus sigma dx dash multiplied by sigma dy dash upon n upon under root sigma dx dash square minus sigma dx का square upon n multiplies up square root sigma dy dash square minus sigma dy up का whole square upon n. So the values are like price and demand is given. The price we will take as x variable and the demand of y will take as y variable. So the values are like 5, 15, 5, 10, 15, 20, 25, 10, 40, 35, 30, 25, 30. Children, I must explain you this is a negative correlations because the value of x variable increases and the value of y variable, that is demand, decreases. We can call it linear correlations as well because the differences are with the same. So children, the same processes we are going to apply it here. The x variables written out here, the y variables values are written out here. So children, again we assumed any value. Suppose we have assumed 15. So 5 minus 15 is minus 10. 10 minus 15 is minus 5. 15 minus 15 is 0. 20 minus 15 is 5 and 25 minus 15 is 10. So the common multiple between the x variable is 5, and this dx divided by common multiple of x variable will get minus 10 divided by 5, it is minus 2, minus 5 divided by 5 is minus 1, 0, 5 divided by 5, and 10 divided by 2, 5 is 2. Then we are squaring dx dash square, so minus 2 square 4, 1, 0, 1, 4. Same way for y variable, we are assuming a 30, ay is 30. So 40 minus 30 is 10, 35, 5, 0, minus 5 and 10. Again the common multiple in between is 5. So 10 divided by 5, 2, 1, 0, minus 1, minus 2. We squaring each of the squaring every dy dash. We get 4, 1, 0, 1, 4. Now dx dash multiplied by dy dash, this is minus 2 multiplied by 2 is minus 4, then minus 1 multiplied by 1 is minus 1, 0, minus 1, 4, and so on. So now when we summarize the given values, we'll get sigma dx dash is 0, sigma dx dash square is 10, and is 5, and sigma d dash y is 0, sigma dy dash square is 10, sigma dx dash dy dash is 10. So the formula is r is equals to sigma dx dash into dy dash minus sigma dx dash multiply sigma dy dash upon n upon under root sigma d dash x square minus sigma dx dash का whole square upon n multiply sigma dy dash का whole square minus sigma dy dash का square upon n. So when this values are being put up, minus 10 minus 0 by 5 is upon under root 10 minus 0 by 10 into 10, this. So on the numerator we have minus 10 left, and on denominator we have square root 10 multiplied by square root 10. So 10 multiplied by 10 is equals to 100, and square root of 100 is 10. So minus 10 divided by 10 is minus 1. So this is called a perfect negative correlation because the value lies as minus 1. So children, this is the way how the numericals of Karl Pearson coefficient of correlations can be solved out. And if you again have any queries or anything which is not clear to us, you can let me know, so that I can give again better solution of your query. So I hope in today's video you will understand all these basic things of solving the Karl Pearson coefficient of correlations. And children, thank you so much for watching this video, and Saira.